Hello, everybody, and welcome to the Geometry Final Exam Review video. Let's get started. All right, questions 1, 2, 3, 4, and 5 have to do with the sum of the measures of the interior angles of any polygon, and they have a very simple formula, which is S, the sum, will be equal to 180 times your n minus 2. Well, what's n? N is your number of sides. So that's really the only tricky part, knowing how many sides a figure has based on the name. For example, a quadrilateral has 4 sides, so the n is equal to 4. A pentagon has 5 sides, so the n is equal to 5. Other than that, we just need to substitute into the formula 180. The n is 4, so I'm going to put 4 minus 2. Well, 4 minus 2 is 2, so 180 times 2 equals 360. Here, it would be 180 times 5 minus 2, which is 180 times 3, which is 540. Simple as that. And that is topic number 1. You do need to know the hexagon has an n equal to 6, that a decagon has an n equal to 10, that an octagon has an n equal to 8. You need to know all your agons, so study them. All right, let's go to topic number 2. Topic number 2 is really telling you there's going to be some questions about parallelograms. So what did we learn about parallelograms? Well, first of all, opposite sides, so DC and AB, are parallel. And opposite sides AD and BC are also parallel, hence the name parallelogram. Opposite sides, like DC, is also congruent to opposite side AB, and AD will be congruent to CB. Opposite sides of a parallelogram are congruent. Also, something you should know about the angles is that, say, angle D, which can also be known as angle ADC, will be equal or congruent to angle B, and angle A over here will be congruent to angle C. But if you got two angles that are next to each other, called consecutive angles, they're going to be supplementary, add up to 180. So let's run by these really quickly. AB is parallel to CD. That is true. That AB is also congruent to CD. That's true. Now, angle ABC. Where's angle ABC? Well, ABC, that angle right there. And BCD are supplementary. Yes, those are consecutive angles. So that's also true that those are supplementary. Let me get rid of that blue there. Actually, right? And then here we got angle ADC and angle ABC. Those are opposite angles. Those are not supplementary. Those are equal. All right? So know your parallelogram facts. I'm not going to do all these for you, but let's see. Oh, wait, I got to get up here. All right, here we go. Questions 11, 12, 14, and 15 have to do with the third side. So let's just say X is our third side. Something that's true about the third side of any triangle, if you know two of the sides, that third side needs to be less than the sum. So when you add the two sides that you have, but greater than the difference when you subtract those two sides. So, for example, number 11. I'll pick one bad one and one good one. All right, let's just say we're testing A. Could these be the sides of a triangle? I kind of don't look at the big one, and I take the two smaller sides, and I'll do it over here. I put the bigger number over the smaller number twice. And in one of them, I do the sum. Here I'm going to do the sum. which is 13. Here I'm going to do the difference, which is 1. That third side, whatever it is, has to be less than 13, less than the sum, but greater than the difference, which is 1. So is 13 in between 13 and 1? And the answer is no, because less than does not mean equal to. So this cannot be the sides of a triangle. So I'm going to jump to the correct answer, which is C, and let's see why. I'm going to take the 2. Again, I'm going to make pretend I don't know what this number is. I'm going to take 13 and put it over 12 twice. I'm going to find the sum, which is 25, and the difference, which is 1. Well, this number, 20, the third side has to be less than 25. It is. And greater than 1. It is. It's between 1 and 25. So that's why this is a good triangle. All right. The only thing to be careful about in these questions is when they ask you the opposite. This one says which one could. That means there's only one good one. When it says which one cannot, that means there's only one bad one. And I'll tell you right now, this one is the bad one. Why? Because if I put 1 and 1 and 1 and 1 and I add them and I subtract them, 2 is not between 0 and 2. 2 is bigger than 2, or equal to 2, I should say. So therefore, this is not. That's a bad one. The only one here that's a little different is number 13. Be careful here. This doesn't say which one could be a triangle. It says which could be a right triangle. And therefore, a squared plus b squared equals c squared. The Pythagorean theorem needs to be true, which means you're going to substitute all of them until you find a true statement. This is the correct answer. I'll show you why. 5 squared plus 12 squared. Is it equal to 13 squared? Well, 5 squared is 25. 12 squared is 144. And 13 squared is 169. 25 plus 144 is 169. That is equal to 169. Therefore, that can be a right triangle. All right. All right. Cool. Okay. Numbers 16, 17, 18, 19, 20, maybe even 21, all are transformation, simple transformation questions. So these, I probably will give you the formulas here. You know, I will tell you that the reflection, you know, when you reflect something, you know, over the x-axis, that means the point, say if it starts, you know, here, it's going to go up here, right? It's like folding the paper, right? It means that the, you know, when you go over the x-axis, the x doesn't change, but you do change the y, right? It goes up and down. And the opposite is here. When you reflect over the y-axis, right, you end up changing the x and keeping the y, right? So right here, you could see that if you keep the x and change the y, keep the x and change the y. So it's going to be 3, 4. And here, if you reflect over the y-axis, you're going to change the x but keep the y. So the 5 changes to -5, but the 1 stays the same. Now here, the reflection over the origin is you change them both, right? So if you have an x and a y, it's going to be -x, -y, which is right there. And here, a reflection over the line y equals x. The formula is yx, which means you're just switching them. So the -4 is going to go in the front, and the 3 is going to go in the back. So -4, 3. You should remember that a 180-degree rotation is the same thing as turning something upside down. So imagine that you had this letter P, and if you were to rotate it 180 degrees, you're just kind of rotating it and putting it upside down, and you can see that it becomes that right there. It becomes really like a lowercase d. And finally, rotation of 90 degrees. The formula for a rotation of 90 degrees was -yx. And that's right there. And finally, do that. Well, here's your x and here's your y. So if you know a rotation of 90 degrees is negative y x, that means you are going to take your y, which is 4, bring it to the front and change the sign, so it becomes negative 4, and then the 3 just flips to the back. And there you have it. Some simple transformation multiple choice problems. I will be giving you a select amount of formulas for that, but you need to know how to use them. All right, these right here, these questions are really designed to see if you remember the very, very important skill that we learned and talked about many times, how to find an angle based on a 3-letter directorate. Right here, like find the measure of angle MAN. Really not that difficult, but it will be if you don't know where that is, right? So how do you find it? Well, the easiest way is to connect the dots. If you want to know what angle MAN is, go to the first letter M, go to the second letter A, and then continue on to the third letter N. You'll see that this right here, this whole thing from here to here, is angle MAN. But then you need to make some calculations. For example, you need to know that that box right there means that that's a right angle. See, it says right there, AM and XG is perpendicular, which means that they meet to form right angles, and they even gave you that little box, which means that that's 90 degrees. But the angle you're looking for is that box plus this 20. So you're going to have to take 90 and add it to 20, and then you can have the measure of angle MAN will be equal to 110 degrees. It is as simple as that. Find the measure of EAX. Well, where is EAX? Well, EAX. Here I'm checking, well, do you remember that this angle and this angle here are what we call vertical angles and are therefore congruent? So if angle GAN is 20, then angle EAX is also 20. So the measure of angle EAX is equal to 20 degrees. All right, that's the idea. I'm not going to do all these. I just want to get through them. All right, now we get to here. These are some circle intersecting chord problems. I guess the most important thing to remember here, let me draw a little circle. Bring that circle over here, right? You know, the thing to remember is that when you have any two chords in a circle, you're really dividing them into 4 parts, right? You get, I'll call that A and B, and this C and this D. And quite simple, the formula is A times B will always be equal to C times D. But then we also learned this other rule that if one of the chords is a diameter, like it is here, and it's perpendicular to the other chord, it's also going to bisect this. That means this part and this part are also going to be the same. All right, let's see if we can do this problem here. It says AE is 16, so I'm going to put 16 in there. It says EB is 4. What is CD? Well, if CD is perpendicular to AB, that means it's bisected. That means I could say, I don't know what this is, but I can say whatever this is, it's going to be the same as that. And now we can just go to the AB equals CD. Well, AB is, say, well, I'll multiply these two first to say X times X is going to be equal to 16 times 4, which means X squared is equal to 64. To get rid of a square, I'm going to square root, and X is equal to 8. That means this is 8, and this is 8. But they're asking for CD, the whole thing. Well, that's going to be 8 plus 8, which is equal to 16. All right, let's do one more, just regular one right here. Here it says AE times EB is equal to 18. So I don't know what this is, right? I don't know what A is, but I don't know what E is, but I do know it's equal to 18. And if ED is 6, and they want me to find CE, I know that 6 times X has to equal what this product is, which is 18. So quite simply, it's 6X is equal to 18 divided by 6. X will be equal to 3, which means CE is equal to 3. All right, let's move on. Let's move it. All right, what do we got here? Okay, these formulas I will be giving you, even though they kind of removed them from the regions, but I'm going to keep giving them to you. So right here, they're pretty much asking for the midpoint. So the formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and it's a point, so it's all in parentheses. So if we go back here, we see that, well, this is x, and this is a y, and this is x, and this is a y. So I'm going to just put them into my formula. So my x's are -4, and I'm going to add it to my other x, which is -8, and divide it by 2. And then I'm going to take the y's, which is 6 plus -2 divided by 2. Now I'm going to add those. -4 plus -8 is -12 divided by 2. And 6 plus -2 is 4 divided by 2. -12 divided by 2 is -6. And 4 divided by 2 is 2. There you have it. That's the midpoint. All right. This other problem, you might remember, is kind of one of those backwards problems, right? Because here they're giving me the endpoints of a diameter and the center of a circle. That's kind of like I got my A, I got my center of the circle, and I got my B, right? So I'm just going to take the information. They're telling me that the center of the circle is 7, -3. And they're telling me that my A is -2, 4. What's B? So it's really like midpoint backwards. And I do have kind of a shortcut that I'll give you. You can sure try to figure out algebraically, but I have a little trick I'm going to do here. All right, I do the x's with the x and the y's with the y's. Let's do the x's first. So I start with my x and I ask myself, -2 to 7 is going up or down? Well, you're counting up, so I'm going to put a positive. And how far? Well, I could use my fingers or just know that from -2 to +7 is +9. You can use your fingers, I don't care. -1, 0, 1, 2, 3, 4, 5, 6, 7. Hopefully you have 9 fingers up. Well, if -2 to 7 is +9, that means from 7 to this number also has to be +9 because this has to be in the middle. So 7 plus 9 is 16. All right, we took care of our x. Now let's go take care of our y. So here, I'm going to go from here to here and ask myself, am I counting when I go from 4 to -3? Are you counting up or down? Well, -3 is a lot lower, so I'm going down, so it's negative. Well, how many? Well, 3, 2, 1, 0, -1, -2, -3. You're going down 7. Well, that means to go from here to here, I got to go down another 7. So -3 down 7, or -3 minus 7 is -10. And there's your answer. 16, -10. All right. Proceeding along. Okay. 33 and 34 have to do with something very important that we spoke about this year, which is perpendicular slope. That's how I like to write it. Perpendicular is the upside down T, and M means slope. And you might remember this when I say it out loud, that what you need to understand to find slope that is going to be perpendicular are 2 words: negative reciprocal. Now, notice there's 2 words. That means there's going to be 2 changes to my original slope. Negative actually doesn't mean it's going to be negative, right? Negative means change the sign. And reciprocal means flip your fraction. So there's 2 things you have to do to find perpendicular slope. You have to know the original slope, and then you take the negative reciprocal, which means you change the sign of it, the opposite sign, and then you also flip the fraction upside down. Some people might understand when I say, well, if you have an original slope, your negative reciprocal slope will be negative 1 over m. That's a little technical, but let's see what we can do here. All right. Well, this is a kind of a complicated problem here because you need to figure out what the slope is before you can figure out the perpendicular. And the only way you're going to know the slope is if you solve for y. So if I'm going to solve for y, I'm going to take my 5y, keep it on this side of the equation. That positive 2x is going to go to the other side, and it's going to become negative 2x, and the 12 stays, so stays positive. And then to solve for y, I got to divide by 5, which means this has to divide by 5, and this has to be divided by 5. And I get y is equal to negative 2 over 5x plus, and I'm just going to keep that as 12 over 5. But most importantly is this right here. The number in front of your x is your slope. So that right there means I have a slope of negative 2 over 5. But the question was, find the perpendicular slope. So I need to take the negative reciprocal of negative 2/5. Well, negative 2/5 is clearly negative. So my perpendicular slope will be positive. And I'm going to flip the fraction upside down. It's 2 over 5, so I'm going to put it 5 over 2. So the answer is going to be positive 5 over 2. I'll do this one really quick. Get negative y is equal to negative 2x plus 7. You got a negative there, so I'm going to just change this to positive and switch all the signs, a little trick. And the m is 2. Well, what is the negative reciprocal of positive 2? Well, positive 2 is positive, so this is going to be negative. 2 is the same as 2 over 1, so this is going to be 1 over 2. So negative 1/2. All right. We are moving right along. Okay. I'm going to clear all that stuff out. All right, now we get, look at that, a couple of this. This means there's going to be a couple multiple choice questions that have to do with volume, the last subject that we discussed. So we should probably read this. Okay. A bulk cereal producer wants to fill a jumbo-sized box with its brand of rice flakes. They decide to fill the box 1 inch from the top instead of filling it completely. How many cubic inches of rice flakes will the producer save by not filling the box to the top? Ooh, how many are, okay, here we go. Well, technically speaking here, the quickest way to do this is to kind of cut off this inch right here, because this is going to be the empty space, right? Oh, right here. Kind of put that there, right? It said it's going to be 1 inch right there. We'll put two little things. That means 1 inch. So if we can figure out the volume of the empty space, we could jump right to the answer here. So it's going to have a height of 1 inch, which is going to be the blank space. It's going to have a length of 8, which is the same on the bottom, inches, and a width of 3 inches. So this is a rectangular solid, so it's length times width times height. And we just need to figure out the volume with those 3 dimensions. The length is going to be 8, the width is going to be 3, and the height is going to be 1. So the volume should be 24 cubic inches. All right, this one I'm not going to do because I can't do it in my head. I don't feel like taking out the calculator, but I will set it up for you. The volume of that shape is what they're asking for to the nearest tenth, right? So they're just saying straight up, what's the volume? Well, it's a rectangular prism, so it's also length times width times height. And the length times width times height is going to be that times that times that. All you got to do is multiply those 3 numbers, and you should get your answer. All right, we went over that one, and I'm not going to do that one for you because you could do it yourself. All right, here we go. Back to circles. Now we're talking about angles and arcs. All right, I don't think this was crazy difficult here. So here we have a circle, a diameter of AOB, and this angle right here has its vertex as the center of the circle, right? Because that's the name of the circle, which means that this angle of 60 degrees has the vertex. Remember, this right here is, we call that the vertex of an angle. If the vertex is the center of a circle, that means the arc, which is arc AC, will be exactly the same as the central angle. So what's the measure of arc AC? Well, if the central angle is 60, then the arc is also 60. Well, here, they're giving me 3 letters and asking for an arc. So I'm just going to trace it out with red here. Now remember, if they give you 3 letters, they want to know the arc that starts at the first letter, ends at the last letter, but goes through the middle letter. So if I want to find arc of ACB, I start at A, I go through C, and I end at B. Oh, look at that. That's exactly half of a circle. We know a whole circle has 360. So if this is half of a circle, right, it's going to be 180. All right. And that is that. Let's move forward. All right. Now look, this angle right here in number 39, the vertex is not the center, right? That makes this an inscribed angle, meaning the angle, like if I call this X, the angle, well, yeah, the angle right here, this arc is going to be double that. It's going to be 2x. So you can look at this as 2 different ways. If you have the arc, the angle is going to be half of it. And if you have the angle, the arc is going to be double it. So let's clear this out and see what we got. It says RS is 64 degrees, the measure of arc. So here's my arc. Remember, the arc is twice as big as the angle, the inscribed angle. So we just got to take half of 64, which is 32. Okay, there's another one like that. Okay, now this one right here is an angle that is formed by, remember, secants and tangents. So we're talking about this angle right here. So remember, if we're looking for this angle, there's 2 arcs that are important. The major arc, which is where that hits and that hits, which is still inside the angle, but on the far side of the circle. And then this one, this arc, which is still inside the angle, but goes towards the angle, which is the smaller one. We really call this the major arc, and we call this one the minor arc, right? The arcs. And the formula says that that angle out there is going to be your major minus the minor divided by 2. All right, let's see what we got. All right, DC is 120, arc DC. All right, let's put it in. Arc CB is 170. All right, that's cool that they gave us all that information, but that arc CB, it doesn't have to do with our formula. However, it will help us find this one that we do know, because if I add 120 plus 170, I get 290, and if I subtract it from what I know a whole circle is, I end up with 70. So that means this right here is 70. Now I'm ready to begin, because they want to find angle A. Oh, easy enough. Angle A will be equal to the big arc that's inside it minus the minor arc divided by 2. 120 minus 70 is 50 divided by 2, which equals 25. Rolling, make sure we're still filming here. I believe we are. If we're not doing this again. All right, and these are just more of the same. I'm not going to do all these for you. I'm not going to do everything for you. You got to do something for yourself. All right, here we got to quadrilaterals. All right, they're giving us a parallelogram. These are a little bit more in-depth questions, but let's make sure we read the given. In the diagram, we see a parallelogram. So everything we know about parallelogram, we have to know about this. And they give us an angle. They give us the measure of angle T of 100 degrees. And they also tell us that SH, this line, this weird line here, is bisecting, meaning cutting in half the measure of angle MHT. That means that this angle here and this angle here have to be the same. That's what bisect means. All right, well, let's see what we could do to reverse engineer this thing. Well, if angle T is 100, guess what? Angle M is also 100 because opposite angles of a parallelogram are congruent. And if angle T is 100, angle A is 80. Why? Because next to each other angles or consecutive angles are supplementary. They add up to 180. Well, if angle A is 80, that angle H is also 80, but it's been cut in half, which means we could put a 40 here and a 40 here. Now, I could figure out this angle kind of easily over here because it's a triangle. I formed a triangle, and they have to add up to 180. So 100 plus 40 is 140, which means this also needs to be 40. And then there's a bunch of ways I can find this angle. And guess what? That's the actual question here. The question is find the measure angle HSA. If you don't know where that is, connect the dots. From H to S to A. You know, this is actually the question. And if we did all that, there's two different ways we can get the answer. One, I could see that these two angles right here on a 40-degree angle and that angle are on a line, which means they're supplementary, which means X would be 180 minus 40, which would be 140. Or I can add up 80 plus 100 plus 40 plus X and make it equal to 360 because this is a quadrilateral and they all add up to 360. Either way, I'm going to get the correct answer. So let me use the quadrilateral method since we're really talking about that now. So I'm going to take 100 plus 80 plus 40. I'm going to add that up, and I get 220. And I know that this whole thing has to equal 360 because it's a quadrilateral. So I take 360, and I minus 220, and I get 140 degrees for that angle right there. All right. Ooh, number 45 is a good one. And if I put it here, guess what? There's a good chance you're saying something like this. Only some of you are going to get this one right. Let's see who among you will get this right. Ooh, I can't. That did not want to do that. That didn't work. I don't have a lot of reach here with my mouse. All right, let me try that again. Do something else. Let's start a new page. All right, yeah. All right, here's a great question. All right. This might be a part 2 question, actually. This might be worth more points. So first of all, they're giving you a parallelogram without a picture. So I would just draw your best one that you can, like that, okay? And after you draw your parallelogram, if they give you the letters, I would also put my letters in. It really doesn't matter if they end up matching up right. So I'm just going to put A, B. Look, if I decide that this is A and this is B, you got to go around in a circle. That means this has to be C and this has to be D. Make sure you don't ever crisscross, right? A, B, C, D. Go in a circle this way, this way. Don't zigzag. All right? They're telling me that angle B is 4x plus 4. And that angle D is 74 minus X. So in a problem like this, you need to look at those two given pieces of information and ask yourself, well, what do I know about opposite angles of a parallelogram? Well, what you should know is that they're equal to each other. So the way we're going to solve for X here is set them equal to each other. So 4x plus 4 will be equal to 74 minus X. I'm going to bring my X's to one side. The 4X stays, so it doesn't change. The negative X travels, becomes positive X. My 74 comes down, doesn't change because it doesn't move, but that positive 4 is going to move over here, becomes negative 4. 4X plus 1X is 5X. 74 minus 4 is 70. I'm going to divide by 5. Divide by 5, X is equal, it goes into 14 times. So X is equal to 14. All right, but that's not the question. If the question said solve for x, we'd be done, but it doesn't. It says find the measure of angle C. Well, guess what? I cannot know angle C until I know angle B and D, because there I have representatives. So I'm going to do B. It says here that B is 4x plus 4. So I'm going to substitute in my x, which is 14 plus 4, and do 4 times 14, which is 56, plus 4. And 56 plus 4 is equal to 60. All right, that tells me that this angle right here is 60 degrees. That means this one also has to be 60. Now, you do need to remember that consecutive angles of a parallelogram are supplementary, which means they add up to 180. So to find angle C, I'm going to take 180, subtract angle B, which is 60, and that gives me 120. And I'm going to be really neat here. At the end of my problem, I'm saying the measure of angle C is equal to 120 degrees. All right, let's go back here, and do you want me to do this one? All right, let's see. This one right here, let's see. All right, they're giving me a parallelogram with an extended side. All right, they're giving me a whole bunch of stuff here. So one thing that I notice is that if I have two parallel lines right here, if this is parallel to this, that means if this is 65 degrees up here, you can almost see how this is true. Watch, I'll even outline for you. Look, see this angle right here? If I just drag that angle down, it's the same as that one. That's what happens when two lines are parallel and you extend it. You get those, they're called corresponding angles. So they're exactly the same. So that means that this is also 65. And if this is 65, that means this is going to be 65. Right? All these things become true here. Now, this right here is 85. Well, I happen to know here, wait, what's the question here? Angle CDB. So CDB is, they're asking to find this angle right here, right? Because if you forget, remember, connect the dots, find the measure of angle CDB. And this is a triangle, and I know a triangle always has to add up to 180 degrees. So I'm going to take my 85 and add it to my 65, right? And I get 150, right? And then I subtract that from 180, and I get 30 degrees. The measure of angle CDB is equal to 30 degrees. Just a little puzzle, right? Just a puzzle. Little puzzle. All right, 47, 48. Ooh, similar triangles. All right, similar triangles. Let's see what we remember about this. Remember, similar triangles, the acronym that I wanted you to remember for similar triangles was CSSTIP. Corresponding sides of similar triangles are in proportion. It really means we could build equal fractions to solve for missing parts. Okay? All right, here we go. Let's put these numbers where they belong in the picture very carefully. DB is 6, so I can see that side right there, so I'm going to put it right there next to it. AD is 2. DE is 9. Find AC, I'll put an X there. Now, the only thing you got to be careful about here is noticing that 2 is not the side of a triangle, but AB is one. So this is when I usually do something like this. I just say, like, well, let's find this long side right here, right? So 6 plus 2 is 8. That means that this side of the triangle, the long side there, is equal to 8. Now we have numbers that we could put into a proportion. And there's a bunch of different ways, so I'm just going to choose one here. All right? So I'm going to say that I'm going to use the smaller triangle here, and I'm going to say that this side over this side corresponds to the bigger triangle, which is this side over this side, right? Those are kind of like corresponding sides. I'm putting the marks not to make that they're equal, but to make it that they're corresponding, right? So I could say, therefore, that 6 over 9, right, if I put the 1 over the 2, should be equal to the 1 over the 2 of the larger triangle, which would be 8 over x. And now it's a simple cross multiplication, right? 6 times x is 6x. 9 times 8 is 72. Divide by 6. Divide by 6. X is equal to 12. And then that x happens to be my AC. So I'm going to write AC is equal to 12. All right, let's look at this one. This was a tricky one. I remember when I first taught this, a lot of people thought this was tricky. Here they only tell you that AD is equal to DC. I know it doesn't look like they're equal, but you got to believe them. If they tell you that AD is equal to DC, you got to believe them, right? And they tell you that DE is equal to 4. Find AB. Well, here's the thing. You know, if I told you that, you know, this was, I'm just going to make up a number. Let's just say if this was 3. Well, that means this would also be 3. And then that means that the longer triangle would be 3 plus 3 would be 6. Well, you could see that the smaller triangle is 3, the side, and the corresponding side is 6. So you could see right there that it's double, right? 6 is double 3. Well, that means that this side and this corresponding side will have that same relationship, that this side will be double that, right? And that always happens when you have this side equal to this side, because this becomes what we call a median, right? And this, which means it'll be exactly 1/2 of the larger side. So here, AB will be equal to double 4, which equals 8. You could even use those numbers and it would work. Watch. If I said 3 over 6, even though I made them up, as long as these were equal, you know, is going to be equal to 4 over x. And watch, it's even going to work. 3x is equal to 24. Divide by 3. Divide by 3. X is equal to 8. All right. There we have it. Okay. 49 and 50, let's see, are what we call the leg and altitude rule problems. I'm going to bring these to another place here. Leg rule and altitude rule. Who remembers those? Yeah, I know. Hopefully you're watching this video and you're going to get this little mini lesson. All right. So let me just remind you of the leg rule and the altitude rule. All right, I'm going to remind you how we kind of got to the derivation of these in class, right? I had all of you remember we made right triangles. We went through it pretty elaborately. So I'm just going to draw a right triangle. And I'm going to do something with this right triangle. I'm going to take it, and even though you know that this is the right angle here, remember I'm going to turn it kind of upside down. And when I turn it upside down, I'm going to drop down what we call an altitude, right? Now, you might remember that if we looked at that big triangle before we turned around, these were what we call legs, right? So here's my A, this is my B, those are the legs, and this whole thing down here was the hypotenuse, my C. But then I dropped down this altitude, which we represent with an H, and when it hit here as a right angle, right, and this was a right angle, it broke my hypotenuse into two parts. I'll call these parts my X and my Y. All right. With that said, we learned two different rules. One rule was the altitude rule, and the other was what we call the leg rule. Okay, let's do the altitude rule first because it's easier. The altitude rule says that whatever the altitude is, h, we're going to put it up here on the top right and down here on the bottom left. And in the other two spaces, we're just going to put the two parts, the x and the y. So it says altitude, if we cross multiply, altitude times altitude will always be equal to this part times this part, the x times the y. That's the easier one. All right, here's the harder one, the leg rule. Why is it harder? Because there's two legs. So first, let's talk about leg A. If I talk about leg A, I'm going to put it up here and down here. And we learn something called the projection. The projection is if this was a tent, remember, and I pulled out the pole, which was the height, this A would fall on top of this part Y. So we call that the projection. We put that down here. And then we put the whole hypotenuse up here. That's one of the leg rules. Or we can use the other leg, leg B. Put the leg B here and here. The projection of that leg is x, so we put it down here, but we also put the whole hypotenuse up there. And those are the leg rules based on that picture. But we also talked about it sometimes with words. Some of you remember it better with words. Remember altitude, altitude, part 1, part 2. And here the leg rule could be, well, leg, leg, hypotenuse, projection. Yeah, this was a big topic. Not easy by any means. And here they want us to find everything. They want us to find everything. They want us to find AC. I'm going to call, right? I'm going to get rid of this. They want us to find AC. I want to get rid of this whole thing here. Bye-bye. So here I'm going to do something a little different, right? I'm going to use variables x, y, and z to represent what they're asking for. They're looking for this leg, which is AC, looking for this height, which I'm going to call y, and they want this other leg, which is I'm going to call z, right? AC is x, CD, and basically we're going to do 3 problems. This is the exact same problem that we did during the year. Exact one. You might see this on your test. Who knows? All right. Okay. Let's begin with AC. Let's find AC first, right? AC. AC is our X, right? Okay. So you have to ask yourself, what is AC? And if you look at the big right triangle, you can see that it is a leg. And with a leg, you also have the hypotenuse involved, which is this whole thing, which I'm going to have to add up 4 plus 5, which is 9. All right. So the leg rule. Everybody, the leg rule. Leg rule is leg, leg, projection, hypotenuse. So we're going to set up a proportion here. Right? I got my leg, which is x, x, my projection, which is 4, and my hypotenuse, which is 9. Now I'm going to cross multiply. X times x is x squared. 9 times 4 is 36. Square root to get rid of the square. X is equal to 6. I'll leave it like that. You know that AC is equal to 6. All right, let's move on to our CD. CD is y. And CD is an altitude. So that's going to be the altitude rule. And the altitude rule is altitude, altitude, part 1, part 2. I know I mixed those up. Doesn't matter. You can put them either place. So here we go. So I got y is my altitude, so y goes here and y goes here. And part 1 or part 2, doesn't matter, is 4 and 5. If I mix up the 4 and 5, it really doesn't matter because we're just multiplying. So I end up with y squared is equal to 20, square root, and I get y is equal to the square root of 20. Now this is irrational, so we do need to simplify that. You might remember we take our square numbers. Hopefully a lot of you remember. We're going to break that up into 4 times 5, right? Because 4 times 5 is 20 and 4 is a square number. So we end up with y is equal to the square root of 4 is 2, radical 5. And lastly, we're going to look for CB. And CB is our z, and it also happens to be a leg, so we're going to use our leg rule again. So z, but the projection of that is 5, and the whole hypotenuse is still 9. So you end up with z squared is equal to 9 times 5, which is 45, square root, and you get z is equal to the square root of 45. Oh, again, we have to simplify this. Well, I'll cut to the chase. It's 9 is the biggest square that goes into 45, and the square root of 9 is 3, radical 5. There you have it. Leg rule and altitude rule. And that brings us to, ladies and gentlemen, the last topic, but it's a big one of this first review sheet, which is SOHCAHTOA. Let's do a little review of SOHCAHTOA. Remember, SOHCAHTOA. SOHCAHTOA is a way to remember that if you're dealing with a sine problem, you always connect it to the angle. It's always going to be equal to the O on top of the H. Ka means if you're doing a cosine problem of the angle, it's going to be the A over the H, right? In the exact order. But if you have a tan of theta problem, it's going to be the O over the A. All right, that was the first thing we learned about SOHCAHTOA. So, for example, if you had a problem, like this, that you were just trying to set up, number 54, right? Remember, you go to the angle, you put a bow and an arrow, and you fire it across the triangle, and that's going to be your opposite side. The diagonal across from your right angle is always your hypotenuse, and then the other side is your A. Remember, the O and the A will always be the legs, and the H is always the hypotenuse. You always need to get rid of one. I need my A. Why? Because there's a 12 there. I need my X, so I keep my H. I don't need the O. Get rid of it. So this is a problem that requires an A and an H. I go down here. Which one of these has an A and an H? Oh, A, H. Oh, this is going to be a cosine problem. You attach the angle. And then you remember ka. Ka means the A on top of the H. My A goes on top, and my H goes on the bottom. Simple as that. All right, let's look at this one. Here's my angle. I shoot it across. This is my O. This is my H, and this is my A. I don't need the A. I need my O because this is 16. I need my H because this is 37. O and H is sine. Oh, it's sine. But what's my angle? My angle is X in this case. And it's still equal to the O on top of the H, which is going to be 16 over 37. All right, keep that in mind here. We have X is the angle. Here we have X is on the bottom. And here's going to be one. Guess what? X is probably going to be on the top. So here's my angle. I shoot this across. It means this is my O. This is my H. This is my A. I don't need my H here because there's nothing there. I need my X and my 18. That's OA problem. So that's tan, which is TOA. So the tan of 34 will be equal to my O over my A, which is... So not only did we just find a sine problem, a cosine, and a tangent problem, we also have one problem where x is on top, another problem where x is on the bottom, and another problem where x is the angle. Three things that you have to be able to do in addition to picking up your tan, cosine, or tangent. So let's do the x on top first. X on top is simple. You just put the other side over 1. I only do that when x is on top. Why? Because if I cross multiply now, I get x times 1, which is x. And then I multiply 18 times tan 34, which I write it down exactly like that. 18 tan 34. You put that into your calculator and you get your answer. Now, let me see if I have my 18 tan 34. I'm going to come over here and open up Desmos. All right, let's see if I can do that with this. I usually don't work with this calculator. So 18 tan 34. And notice how it gave me a negative. That means I'm in radians. That's okay. I can just go here and switch this to degrees. And you can see if I was going to round this off to the nearest tenth, it would be 12.1. So I'm going to go here and say x is equal to 12.1. All right. How do we do an x on the bottom? Remember, x on the bottom is going to be the volleyball trick. I throw the 12 to the other side, and it lands on top of cosine 20. So that's a division problem. So I go to my calculator, and I do 12 divided by 12 divided by cosine 20. And I would round that off to 12.8, right? Because that's second 7, 12.8. So I'm going to go back here and put, x is equal to 12.8. And then finally, what do we do when x is the angle? Well, when x is the angle, we got to somehow get the sign to the other side. So we write x is equal. We send the sign to the other side, but it becomes an inverse function to the power of -1. And then we just drop the fraction into there, 16 over 37. Let me see if I can figure this out on this calculator. So it's sine to the power of -1. I don't know if that worked. Is that really going to do it? I don't think so. I'll be surprised if this works. And what was the, I probably have to go into the calculator. What is it? 16 over 37. Oh, look at that. Oh, look at that. And the answer is 25.6. Which rounds off to 26 degrees. This was a multiple choice, so they rounded up to the nearest whole number. So there you have it. All right. That, everybody, concludes review number 1. There will be a review number 2, but I hope that you find this video useful in your review of the Geometry Non-Regents final exam. All right, everybody. Don't forget to like and subscribe. See you later.